Museum, and I'd like to welcome you tonight. Thank you for coming to tonight's talk, which kicks off the museum's 2019 Fall Archaeology Lecture Series as part of the statewide celebration of Oregon Archaeology Month. I'd also like to remind you that the next talk in this series is by University of Oregon anthropologist Dr. Allison Carter, which will happen on October 17th. And her title of her talk is called Looking Beyond the Temples, Exploring the Ancient Residences of Angkor. She works in Angkor Wat in Cambodia, and she does some really interesting stuff, so I hope to see you all there. Before I commence with the introduction, I'd also like to remind everyone that tomorrow is Free First Friday at the museum, which we do on the first Friday of every month. In addition, it's also Go Ducks weekends, where during every home football game you can get 20% off your one-year membership to the museum. And finally, October 12th kicks off the grand opening weekend of Racing to Change, Oregon's Civil Rights Years, Eugene Story. This is our new exhibit co-developed with the Oregon Black Pioneers, which illuminates the legacies of racism and the unceasing efforts of Oregon's Black communities to bring about change as seen through photographs, recorded interviews, and historical archives. Racing to Change explores how racist policies and attitudes created a pressing need for bold civil rights activism in Eugene. There will be performances by the U of O Gospel Choir and the Powerhouse Praise Team at around 12:30, and opening remarks at 1 o'clock. Admission to the museum is free all weekend in celebration of the new exhibit, so bring your friends and family.
Is that on Saturday?
That is, yes, Saturday, right? Yeah. A week from, yeah. October 12th. So without further ado, tonight we're pleased to have Dr. Jaime Kennedy. Jaime has been a duck throughout her career, having completed her BS in anthropology here in 2003, a Master's of Science in Interdisciplinary Studies in 2010, and her PhD in anthropology in 2018 under the guidance of Dr. Young Ali. Jaime's research interests focus on paleoethnobotany in the Pacific Northwest, particularly the Great Basin, where she has conducted her dissertation research and many, many other field projects. She's primarily interested in the interaction between humans and their environments across time and space, and the role that humans have played in altering landscapes. Some of her most recent research has been published in the Journal of Archaeological Science, as well as numerous technical reports on projects in Oregon, Washington, and more recently in Scotland. Jaime has a long history of volunteering and working with the museum, going back to her undergraduate days, and the museum was extremely pleased when we were able to hire her as one of our new research associates last year. Please welcome Jaime as she presents her research entitled People and Plants, Foraging in Oregon's Ancient High Desert.
Can you guys hear me? Am I talking like this? Okay. Thank you for the introduction, Scott, and thank you all for coming out and having me here today to talk about my research. So I'm a paleoethnobotanist, as Scott mentioned. I work with the research division at the museum as an archaeologist going out and doing CRM research, but my passion lies with paleoethnobotany and studying people and plants. At the broadest level, my interest and concern is studying how people interact with their surroundings, as Scott mentioned. He knows me so well. Looking at how past behaviors, once they become enculturated into a group of people, repeated and passed down, can influence both future generations' behaviors and landscapes through time. So, just in a broad sense about paleoethnobotany and why paleoethnobotanists are interested in studying this, it's because there was some tipping point about 10,000 years ago where people went from being hunters and gatherers and collecting their food and foraging to making their own food, producing their own food. And food production became inextricably linked to agricultural practices where sowing and fertilizing and tilling the land leading up to this, the scene was set by people who practice hunting and gathering lifestyles, foraging for plant foods on a daily, weekly, or maybe monthly basis, depending on what their storage capabilities were. And this was 99% of human history, essentially, where the hunting, fishing, gathering lifestyle has people interacting with plant species, and evolution in and of itself is a crazy thing, but plant evolution is wildly crazy and varied. There are multiple ways that plants can propagate and reproduce, and people's interaction with these plants through time, these evolutionarily malleable beings that they are, led to changes in their genetic makeup, so that eventually, in really overly simple terms, in the course of numerous generations, there's a palpable shift in how plants look when it comes to domestication. So the most obvious example we have is teosinte into maize, right? So the images on the left-hand side are all the wild precursor to maize. There's that corn kernel that we're all familiar with that's laden with sugar and carbohydrates and calories, and it's a good thing to eat, tastes delicious. But next to it is a teosinte kernel, which basically looks like a pebble. So how did these hunters and foragers and gatherers make their way through the world with these plants that hadn't been already manipulated? So my research interest and the focus of my talk tonight is on just a small sliver of this big picture stuff. And that's looking at the foraging pursuits of hunter-fisher-gatherer groups in Western North America at the end of the terminal Pleistocene, about 2,000 to 5,000 years before the origins of agriculture. Here's my not to scale, not appropriate probably slide. The material culture left behind by these foraging groups, including the plant and animal food remains, is especially interesting because it currently represents the earliest knowledge, evidence we have for people in the Americas. People living in the Americas during the terminal Pleistocene were the earliest human colonists on the continent, and their decisions about where to camp, how to hunt, what to forage, it was all happening in new environments and unique ecotones. And to be able to find evidence of their material culture thousands of years later in itself is just remarkable. There's small bands of highly mobile foragers on the move with a very ephemeral archaeological footprint. As you all probably know, though, some of the oldest known Paleo-Indian sites are right here in Oregon's Northern Great Basin and have been studied by museum archaeologists. So, I'm just going to start off by providing a bit of background on Paleo-Indian archaeology in the American West, because I'm sure most of you have had a primer on this already. And then I'll go into talking about some of my dissertation research and how it fits into the bigger picture. So, some of you may have attended last year's Museum Fall Lecture Series. Dr. Todd Brady gave a talk about the current state of research pertaining to how and when migrations to the Americas took place. I'm not going to reiterate everything he said, just go over the fact that there are two main routes that have support among the academic community. The first is the route over land from the Ice Free Corridor from Siberia down into the Americas, and then a dispersal throughout North and South America. And then the second is the Pacific coastal route along the margin of the west coast of the United States. There's linguistic, genetic, archaeological, paleo-environmental evidence supporting both theories, but debate really lies in the question which route was used first. So we know from recent research that the Ice Free Corridor didn't open until until after 14,800 years ago. And this fits with the story that we knew through most of the 20th century, when all of the Paleo-Indian sites that we knew about were associated with Clovis voodoo point technology. Clovis sites are present throughout North America, and they have a very limited horizon, about 12,900 to 12,600 years ago, where we have all of these sites. It was generally accepted that people with Clovis technology followed big game over the ice-free corridor after it became passable. But as archaeologists continued to actively look for old sites, and they were able to better refine their predictive models to understand where old sites might be found, they started encountering Paleo-Indian sites with a different type of material culture. And as new Paleo-Indian sites were identified, the Clovis first story started to make less sense. Paleo-Indian archaeological sites in places like the Paisley Cave in Oregon, Mesa Verde, Deborah L. Friedkin, Rimrock Draw, among others, have radiocarbon dates that predate that Clovis horizon, and scholars began to question the validity of the ice-free corridor as the initial passage into the Americas. Currently, where we stand, there was recently an article published in Science by Oregon State archaeologist Lauren Davis and his research team that found evidence of Western stem points in buried context at Cooper's Ferry, Idaho, which is on the Snake River Plain, about 16,000 years ago. So it's the oldest definitive site that we have right now. And it definitely predates the opening of the ice-free corridor 14,800 years ago. So Dr. Davis and his team concluded that it probably shuts the door on the ice-free corridor being the first access point into Americas, and the coastal route is actually probably more correct. And on top of that, he went on to say that he could identify, as other people have suggested in the past, that the Western STEM tradition has technological antecedents in Japan, the Sea of Japan area. So we can trace back the technology from North America back into the Pacific Rim area of Asia. So, although these sites exist, they're very far and few between. We don't have a lot of these unicorn sites with super old dates. We do have a lot of Western STEM sites, though, and they tend to show up around the same time that we start seeing Clovis showing up, about 12,900 years ago, which also corresponds with the onset of cold snap globally in the climate called the Younger Dryas period. So that started about 12,900 years ago, and consisted of a 1,200-year cessation of the retreat of glaciers, and globally characterized a big temperature drop, and in the northern hemisphere, windiness and storminess. So climate change wasn't uniform across the whole world, but we do know that from Oregon, there are speleothem data that show that conditions gradually became cooler and wetter. Lake levels fell, creating more biotic diversity in shallow lakes and marshes. And so that southern Oregon area in general was characterized by a cool, moist steppe environment. And that's where we find ourselves looking at the foraging data in Oregon's ancient desert. There's the scene that's set. So looking at plant data, I'm interested in looking at any Paleo-Indian plant data, whether it be from a Clovis site or a Western STEM tradition site. But the problem is that there isn't a lot of plant data associated with Clovis sites. Clovis sites tend to be in open settings and associated with big game kills. That's not always the case, but generally. So this table here shows, it's adapted from a publication publication from 2004 that lists all of the Clovis sites that actually have plant data associated with them where edible plants may be present in the site. You can see there aren't very many of them. Shawnee Mini Sink in Pennsylvania is the only one that actually has a plant assemblage associated with it. All the others are one nuts or a couple of seeds. It is worth noting too that hackberry shows up a lot in these open sites, and hackberry is very tough. It can stick around for a long time and isn't as susceptible to differential preservation processes. So some people have suggested that the Clovis hunters were more concerned with capturing big game. That was the prey that they went after. And to lower themselves to chase after some small mammal or go forage some plants meant that there wasn't enough of the big package meat around for them to get to. But I do think we have to take into consideration definitely the differential preservation processes that are happening, why we're not seeing as many plant remains associated with Clovis. In contrast, luckily for us, especially in Oregon, the old sites with western stem components a lot of times are located on lake or marsh margins, in upland locations, and in rock shelters. And rock shelters have excellent preservation. They have, so animals and plants are better preserved in these conditions, and so they're a really good place to look for information about Paleo-Indian subsistence, especially in the younger dryas where we have the first real good information about Paleo-Indian foragers. So research on food remains in rock shelters is not at all a novel enterprise. People have been doing it for a long, long time. But understanding the plant use among Paleo-Indians with a Western stemmed tradition toolkit, something we're still in the early days of synthesizing. So there are multiple research avenues we can pursue to find out about what types of plants people are using. We can look at the remains themselves, the macrobotanical remains, which is what my specialty is. And that's just looking at actual seeds, looking at charcoal fragments, the fruits and roots and tubers, leafy greens, anything that actually is big enough for you to see with your naked eye is considered a macrobotanical remain. And we find those in features like hearths. There's also, you can also look at a pollen analysis. So lots of times pollen analyses are done for paleo-environmental reconstruction. So in lakes that are perennially wet, you get a good lamination building up, and you can have a really good definitive diachronic understanding of regional vegetation at the time. But you can also analyze pollen from archaeological contexts, and I'll talk a little bit about that later. Coprolite analysis is amazing, where you have coprolites available, which we do in these rock shelters in Oregon, because you're actually looking directly at somebody's consumption patterns. You're not having to make any interpretations about, oh, the seed is in a hearth. Was it meant to be there because it was part of somebody's dinner, or did a rodent drag it in and it just became part of the archaeological record? Starch analysis can be done on tools in archaeological sites, so and not just starch, I guess any residue analysis. If you're looking at faunal remains and trying to identify them in the absence of bones, if you have protein residues on tools, we can identify what those are. And then the tools themselves, so looking at basketry, nets, traps, not only the materials that these artifacts are made from, but also what's their use? What are they going to be used for? For fishing, for collecting berries, et cetera, et cetera. And so we have all these options of research. And in the case of Paleo-American diet and just subsistence in in general. What is driving the research are questions about diet breadth, subsistence strategies, what plants are targeted over other plants, seasonal visitation patterns, and then of course looking at differences between regional areas and looking at differences through time, how people's interaction with plants have changed. So, my colleague Caitlin McDonough shared this image with me. She is heading up a chapter that there are, I think, more than 5 of us hopefully on board to do a study on Western stem subsistence that is going to be published in the University of Utah Press publication that looks at current perspectives on Western stems and Clovis in the far west in general. These are all sites with a Western stem component in the Younger Dryas, the green circles. And then the little bones there represent sites where faunal studies have been done or are underway, and the leaf where plant studies are being done. So there's not a lot to work with yet. We're still building our database. But I wanted to provide you with a singular case study to show sort of the state of where we are right now. And that is from the Paisley Caves in Oregon. Part of my dissertation research was focused on looking at plant remains, the macrobotanical remains from different contexts at the site in Paisley. So the Paisley Cave is honestly a really excellent site to showcase a case study for research on Paleo-Indian plant use, and that's because of the vast number of researchers that Dennis Jenkins has invited to the study. And most of the information that I'm going to be presenting now is my original research, but it's also complemented on research from colleagues who have conducted independent analyses of pollen profiles, coprolites, starches, etc. So here we have the location of the Paisley Cave. It's in the Summer Lake Basin. It's in a series of wave-cut rock shelters that sit above the valley floor in the Summer Lake Basin, which was Fluvial Lake Shuapon. The caves themselves were formed 18,000 or 19,000 years ago by wave action from the lake when the lake stand was higher. But as lake levels dropped, people were able to inhabit the caves, which was a really great campsite because it was located at the edge of a bunch of different resource zones. You have the marshy resource zones down on the floor, and then to the east, in the hills, you have upland root grounds, and the grasslands that are created around the marshlands are really great forage places for big game to travel. So both Luther Cressman and Dennis Jenkins systematically tested caves 1, 2, and 5 at the Basin Caves over the years, and they together, the research has shown that Western stem tools were found in association with megafauna. Human coprolite there was dated to about 14,500 years ago, which predates the Clovis horizon. And there are numerous features that have been identified. Some of those features were in Younger Dryas contexts. And so part of my research was looking at features from Younger Dryas context in caves 1 and 2. Altogether, I processed about 35 samples for my dissertation, and of those, I'm going to talk about 8 samples. 5 represent Younger Dryas hearths, 2 represent a cultural deposit we call the botanical lens, and which is also dated to the Younger Dryas, and finally didn't necessarily look particularly at a feature, a cooking feature, but I wanted to see how the makeup of different seed taxa changed through time and in different contexts. So there are a few samples from the bottom of that column sample that date to the Younger Dryas, and then feature samples in Cave 2 and Cave 1. These are a couple, hard to see, Cave 1 features that I looked at. They're dated to about 12,500 years ago. And then Cave 2, here is the profile for the column sample that I took, and then some of the feature samples. And one of Dennis's students here is excavating botanical lens. As you can see, it's chock full of stuff. So the upper and lower mud lens sit on top of the basal layers, and they're separated by the botanical lens in the profile. The lower mud lens and the botanical lens both date to about 12,900 years ago, so we're fully in the Younger Dryas period. The botanical lens is about 5 to 8 centimeters thick, which isn't very thick, but it contained a ton of organic material, so I'll just read off some of this. Mainly sagebrush twigs and shredded bark, but also dense clumps of pronghorn underbelly hair, culturally modified pronghorn bones, jackrabbit bones, heron hides, charcoal fragments, cordage, obsidian debitage, disaggregated coprolites, crystallized urine, bones, feathers, mummified flesh, claws, wood rat, and bat feces, and hair and hides of marmot, hare, and vole. The botanical lens also had 2 unlined hearths that were identified in it, which I also looked at for this study. So these were some of the constituents I recovered from samples that I collected in the hearth. So fish bones, cut fur, bird feathers, pronghorn hair, insects, cordage. Typically, methods for looking at macrobotanical remains in archaeological sites involve adding water to the soil samples, because seeds, charcoal, the kinds of stuff that I'm interested in looking at are buoyant. They'll rise to the top, all the heavy stuff will sink to the bottom. So the dirt, the lithic debris, because we don't care about stones, so I'm just kidding. The lithic debris, the bones, the faunal, so I do go back and look at the heavy fraction too, but separating out the light fraction really just consolidates the botanical material. It makes it easier to look at under the microscope to identify it. But I tried to do that with one Paisley sample. It was a really bad idea, because instead of the seeds just floating up to the top, the coprolites disaggregated, the bat guano disaggregated. Well, there probably weren't coprolites in there, sorry, I don't want to offend anybody. The bat guano disaggregated, so it just became this like ooze of mush that rose to the top. And it got worse because when I set it aside to dry, it just didn't dry. It started growing mold. So my husband and I got kind of scared that we might be reviving some ancient disease, airborne toxic deal. But I don't know, the CDC didn't contact me, I assumed nobody got sick. I threw the sample away and basically dry sieved the rest of them, which is a lot more time consuming, but was very effective for this case study. Don't do that. Don't do it. So once I identified and counted all of the uncharred and the charred seeds from each context, I plotted them into a cluster analysis. And I found that the Younger Dryas hearth samples, which are right here, all cluster together, which is good, right? It tells us there's something statistically unique about those samples of the hearths in the Younger Dryas. The non-hearth samples did not cluster with those, which makes sense. They aren't cooking features. We didn't find very much charcoal, and actually hardly any charred seeds at all in these non-hearth Younger Dryas samples. So It's really hard to make an interpretation about whether these uncharted seeds are cultural or not. There's a lot going on in complex histories of rock shelters, and the seeds may have been brought in by people intentionally, but they could have just as easily been brought in by scavengers or blown in. So it's hard to make any real interpretation about those seeds contributing to diet or having to do anything with subsistence. You'll see that in the non-hearth mudlands, there was 2 charred seeds that were both blazing stars. So I don't know if you're familiar with blazing star. It's a pretty common plant in the high desert. It's got little yellow flowers on it. Its seeds are edible, and it's actually among the plants gathered by people in the traditional economies of Great Basin indigenous folks. But other than that, in the botanical lens, we only have uncharred seeds, and it's dominated by Indian ricegrass. Indian ricegrass is also an edible seed and is very well documented as being an important taxa in the diets of people living in the northern Great Basin at the time of Euro-American contact. But it's also a favorite seed of wood rats. So my feeling is that our little wood rat friends living in the Paisley Caves probably brought in a lot of these Indian ricegrass seeds. Because when I do look at the hearth samples and look at the charred seeds, which I feel confident in interpreting that represent food remains, ricegrass only accounts for about 6%, which is pretty low percentage-wise. I would expect to have it be more relatively abundant if people were actually targeting that for food. Instead, what we do see is a lot of reliance on kinopods. So kinopods are also traditional in the economies of Great Basin people, and there's a couple pictures of them there. Kinopods are ubiquitous, definitely in the Americas and elsewhere. It's actually been domesticated, the Kinapodium species, domesticated independently twice around the world, once in the southeastern USA and another time in the Andes. And you guys are all probably pretty familiar with that food because it's modern day quinoa. So it's the same taxa, Kinapodium here and quinoa. So quinoa, as you know, comes in different colors because we selected for those attributes, but the wild Kinapodium that grows in Oregon and elsewhere is black. So even though these are charred samples, it would look black even if it was uncharred. So Kinapod, we're seeing plants in the borage family show up, and grasses. So again, all really interesting because they're all plants that are important in the traditional economies of people living in the area. And we're talking about people using them 12,500, 12,900 years ago and into the present. One other thing about the kinopods in here, so they do require some processing. You can't just eat them straight. They have a seed coat that needs to be rubbed off. So we don't have any evidence for well-developed grinding tools in the Paisley Caves during the Younger Dryas. So my feeling is that people are probably collecting these, processing them pretty expediently and eating them immediately. They're not gathering a whole bunch, processing them, and storing them for later. So turning our attention to charcoal, we can see that sagebrush is a big favorite for fuel wood in Younger Dryas hearths. There is some willow charcoal that's in the botanical lands and the mudlands, which speaks to the fact that there probably were large resources closer to the caves then than there are now. But by and far, sagebrush was a very happening fuel wood to use. And honestly, like, if you can imagine the stench that's coming off everything in there, I wouldn't mind burning a little sage to help me make my dinner more palatable. information we can derive from looking at plant food remains is that we can tell the time of year people are visiting campsites. Plants generally have predictable flowering and harvesting, fruiting times, and because most of the evidence, pretty much all the evidence we have for this site during the Younger Dryas is that there wasn't any storage happening, we can pretty confidently say that when the plants were collected is when they were fruiting, when they're available for harvest. So this seasonal availability chart is based on data from the USDA about when plants fruiting and flowering times are. And rather than just show you what I found for the Younger Dryas, I showed for the entire period of occupation for the caves from the late Pleistocene, which I actually didn't find any plant remains from pre-Younger Dryas components. Early Holocene, Middle Holocene, and late Holocene. And what this graph shows is that people at Paisley Caves had flexible reactions to changing environmental conditions, changing cultural needs, so that over time they might visit the rock shelters during different periods of the year. During the Younger Dryas, we see them there in generally the summer, fall, maybe into late fall. And there is some archaeological evidence that provides corroborating data, which suggests that small groups of people, 20 to 30 people, were camping at the rock shelter at a time and processing the pronghorn hides to make blankets for winter, hence all of the pronghorn hair everywhere in the samples. I apologize for this slide. I know you can't read it. I'm sorry, but I will tell you that the red line here represents the Pleistocene, Holocene boundary. The yellow lines represent the beginning and end of the Younger Dryas. And these samples over here with the dates represent the column sample that I took in Cave 2. And all I really wanted to point out with this slide is that we see a change where we have mostly mesic-adapted grasses, and even before the Younger Dryas, but continuing into the Younger Dryas, some wetland plants. But after the Younger Dryas is over, there's more of a shift to higher relative abundances of xeric-adapted plants that show up. So this is the slide that actually tells you that. The taxonomic makeup of the macrobotanical assemblage, I also compared that to previous pollen investigations that were done in the cave. I mentioned before that rather than just regional pollen signatures, sometimes we can get local signatures if we do pollen analysis on archaeological deposits. And so one study was done by Chantal Sabin, who did a pollen analysis for her master's, and the other was by a fellow named Chase Beck, who did the same sort of research for his dissertation. So I mentioned before, Dennis invited a lot of collaborators to come into this. Another kind of cool thing is that we have similar studies going on at the same time, and we can compare the results of those to see how much overlap we have in the results. And they overlapped quite a bit. So Beck et al. Found evidence of buckthorns and a little bitterbrush and willow during the Younger Dryas. And Sabin noted increases in mesic-adapted plants that correlated with increases in the number of formed stone tools that we're finding in Paisley Caves at that time. So she made the connection in her master's thesis that people were coming to this area because of the resources available at that time. During the Younger Dryas, there was low floristic diversity in the Paisley Caves pollen records. It was dominated by pine and other conifers, sagebrush, some Kinapods. There were scattered shrubs and forbs, which support previous regional paleoclimate reconstructions that suggest a moist steppe environment at that time. But Beckett also postulated that pine trees might have been present on the site during that time because of the amount of pollen that was in the samples. But pine pollen is an airborne pollen. It looks almost like a little Mickey Mouse head. It's got big ears on it. So it can be carried by the wind really far distances. So I was interested in looking at whether or not the macrobotanical record could corroborate that or not. And what I found was that there were pine seeds actually in the botanical lens, along with juniper seeds, but there were no pine needles. And for as much as pines shed, I would assume to find pine needles in the site if there was actually a pine tree right nearby. So it's probably up a little above the site. Okay, next. 2 different studies have been undertaken looking at the actual coprolites from Paisley. So this isn't my research, but it's really cool, so I wanted to tell you about it. The first, by Taylor et al., looked at a bunch of coprolites from both the early periods at Paisley and also later on in the late Holocene. I'm only showing you for both of these studies the coprolites that dated to the Younger Dryas, since that's what my data set is. So Taylor found evidence of small mammals, and medium-sized mammals, and large mammals in the coprolite. So his evidence was little hairs and bones that had gotten incorporated into the coprolite. And then the coprolites, in some cases, also had seeds in them, which is pretty interesting because the seeds that he found in the coprolites dating to the Younger Dryas are the same seeds that are in the hearth. So, yay, I didn't misidentify everything. He also found, or that team also found that he could only say definitively that the pollens represented in the coprolites, only Kinapods were intentionally ingested for sure. So all the other pollen types that showed up weren't in large enough quantity that that research team felt that they represented anything but ambient pollen that people are breathing in or accidentally ingesting. Long et al., whose study has not been published yet, he was kind enough to share this data with me ahead of publication, found a varied diet as far as the faunal record went. Small rodents, insects, fish, hares, birds, and large mammals. So quite a complement of protein in the diet of these people. And as far as the actual macrobotanical seeds went in the coprolites, he found a little bit more. He also found Kinapods, like Taylor et al. And I did, but also sedges, so another wetland plant that would have been growing along the marsh, and rose seeds, so little rose nutlets, which he interpreted as people eating rose hips, which makes sense if they're growing around there. They're really high in vitamin C. That's probably some nutritional value that they're not getting from other sources. And it sort of makes sense that they're not in the hearth, right? Because when you're talking about eating your fruit like that, you're consuming the entire fruit. There's less of a chance for pieces of it to fall into a fire. Whereas when you're processing small seeds like Kinapods, you're going to lose some. Some of it's going to be incorporated into the archaeological record. As far as the pollen types went that he felt people were intentionally ingesting, it also included pea flower and cattail. So not sure, the cattail pollen levels weren't as high as you would expect if people were eating the cattail pollen itself, which is a traditional food, but it is there nonetheless, and also grass family pollen types. And that was reified by the fact that he looked at phytoliths in the coprolites, and phytoliths are little silica bodies in plants that are virtually indestructible. They just have weird shapes, but people are crazy and can identify them, and so we found grass family phytoliths. story for this coprolite analysis is that Taylor and Blanc both felt that what they saw was representing a broad spectrum diet and sort of an ancestor diet to the traditional Great Basin diet that we see. But Taylor felt that his results showed that the people at Paisley Cave were probably leaning toward carnivory, which I tend to agree with, based on the fact that of all the hard samples that I looked at, I only identified less than 150 charred seeds, so I would expect more than that. So this is an old map from Bray and Stern that shows tribal distribution in the area of the Paisley Caves. And then a picture of some Paiute women gathering seeds. So I didn't show this data because I'm focusing on the younger dries component, but in the later samples from the middle and the later Holocene, we do see many more small seed processing or evidence for that through the blazing star, a lot more than that, and a huge explosion in the amount of Kinapod seeds that we're seeing. So I think that diet that's geared towards carnivory is probably correct, but again, they were eating insects, they were eating whole rodents, they were eating everything they could, so reflective of a broad spectrum diet. So Blanc et al. Also did a seasonality study, and I really like his little pictures, they're really cute. So only those little people, so the people represent the donors of the coprolites, but only those people in the pink square there are people that donated their DNA during the younger dries. So I'm just focusing on the coprolites 55, 56, 98, and 195 and talking about this. But he found that during the younger dries, people were visiting the caves during the summer and fall primarily, as represented by the colors associated with each of the little people. And that they ate nuts, rabbits, birds, fish, rodents, grasses, dicots, and flowering plants. So just a lot of stuff. So all that research is great because now it gives us a basis for actually interpreting some of the data. So just looking at my data alone in a vacuum isn't as helpful as looking at all of the research avenues together to help. So in putting it all together, what do we see? We see that the visitors to the Paisley Caves were probably local foragers. They're moving around the caves and foraging a variety of plants, including grasses, quinoams, blazing stars, forages, pea flowers, rose hips, tansy mustards in a lesser degree. They also utilize the nearby marshes to acquire plants, probably used for fiber and mats and basketry. They were visited primarily in the summer and fall during the younger dries. And the hearths that I analyzed here are small hearths. They're likely not hearths that were used over and over again by generations of people returning to the caves, as we see from other sites. They were used on a very limited time basis and don't represent a very long period of use, but could have been, reused over and over again during a single camping trip. And we see that, after all, Paleo-Indian foragers in the younger dries have a pretty broad spectrum diet consistent with ethnographic data. And again, I hope that we can go back to some Clovis sites that actually have good preservation and look at that again. So wrapping up here, a really exciting component of this archaeological research at the Paisley Caves has been the opportunity to study various aspects of the past. So studies crossing disciplinary lines, but they also cover various scales of analysis. Subsistence studies alone include faunal analysis, botanical, pollen, starch, coprolite, etc. But the temporal scale of the data also differs. So seeds and charcoal in a feature might represent a few families' camping episode over the course of a few days or weeks. But the seeds and the coprolites themselves represent 1 or 2 meals consumed by a single person. That's pretty cool. And this type of integrative research can really help us to develop a regional synthesis to better understand Western STEM tradition culture, especially as it relates to their subsistence strategies and food preferences and seasonal rounds. So it's pretty cool to be able to get into the heads of people that lived 12, 13,000 years ago and understand their culture and what they were doing. So here's that map again, and I just wanted to say that the next time I give a talk on this subject, I'm certain there'll be more dots on the map, and certain that there will be more little bones and more little plant leaves, because I know there are a lot of studies underway, and it'll be really exciting to bring all that data together in a more regional synthesis and diachronic synthesis, so we can really start to gauge what's going on, not just at one location, but across entire landscapes. So it can help us to answer anthropological questions. But it's all about. So. Thank you.